a ninth planet was hiding in our solar system. Some astronomers are convinced of that anyway. It all started on January 20, 2016, when Konstantin Batygin and Mike Brown, two astronomers from Caltech, the California Institute of Technology, proposed the existence of a planet 10 times the mass of Earth, in orbit several hundred astronomical units from the Sun. What is an astronomical unit, you might ask? It's a reference that measures the distance from the Earth to the Sun, quite simply, which is about 150 million kilometers. So, in the far reaches of the universe, or rather, the far reaches of our solar system, there could exist a ninth planet. Its existence would have been indicated by the unusual orbits of several objects in the Kuiper Belt, that area extending beyond Neptune's orbit. The calculations made by scientists found that this planet 9, also called by some planet X, would be an ice giant like Neptune, a mass between 5 and 10 times that of Earth, and it would take between 10,000 and 20,000 years to complete its orbit around the Sun. Following the discoveries about exoplanets, which have multiplied since the mid-90s, we know that there are billions of planets similar to Earth, which could contain sources of life. Some call these planets super-Earths, formed through migration processes during the formation of planetary systems. We can think that our solar system also initially had several super-Earths, but the laws of celestial mechanics and gravitational disturbances could have led these super-Earths either to be swallowed by the young sun or to be diverted onto particularly eccentric and large orbits. It's this eccentric position precisely that makes things a bit more confusing. To understand this, you first need to fully grasp Kepler's laws, which describe the main properties of the motion of planets around the sun. Indeed, to put it simply, from Kepler's 3 laws, we understand that the farther a planet is from its star, the slower its speed. As a result, a huge planet lost in the far reaches of the solar system would not only be dim because of its distance, but its movement would be so slow that it could be mistaken for a star. Although its existence is still speculative, the hunt for the 9th planet in the solar system is on. Since the announcement 3 years ago, further studies have been conducted, yielding results less bold than those initially put forward by Batygin and Brown. It is now reasonable to think that if it exists, the new planet would contain only 5 times the mass of Earth, and that it would be a little closer to us than initially thought. At only, in quotation marks, 400 astronomical units, which is about 60 billion kilometers. Konstantin Batygin explains that with 5 Earth masses, the 9th planet would probably look a lot like a super-Earth. It's the missing link in how planets formed in our solar system. For about 10 years, the study of exoplanets has shown that large planets are very common around other stars similar to the Sun. And the two researchers think that we could actually discover our super-Earth, this super-Earth, in our own solar system before 2030. We are indeed talking about a super-Earth here. So it would not be a dwarf planet like Pluto at all, Mike Brown tells us. Indeed, according to him, with its estimated mass, a planet of such size would gravitationally dominate its immediate environment. It would meet the conditions that make it a real planet, just like Earth or Jupiter. But since this astronomical object is very dim and very cold, it's not surprising that it has so far escaped all detection, even with our most advanced observation instruments. Many other giants have been detected in very close orbits around their respective parent stars. This confirmed their existence. First, frequent migrations of planets in young planetary systems, then frequent migrations. Many exoplanets, whose masses would be between those of Earth and Neptune. These are the exoplanets we call super-Earths. Researchers then tried to model the formation of these planets. The first results obtained made it possible to deduce, with a hint of caution however, that our own solar system probably contained in its early days a super-Earth or another gas giant. This body would then have been propelled out of the solar system due to gravitational interactions with Jupiter and Saturn, eventually ending up in a distant orbit far beyond the Kuiper belt. A few years ago, David Nesvorny, a researcher at the Southwest Research Institute, came to this conclusion that, without a fifth giant planet similar to Neptune and ejected by the gravitational disturbances we just mentioned, Venus and Mars would likely have been destroyed. That same Dr. Nesvorny also hypothesized that the existence of this Neptune-like cousin could help explain one of the mysteries of our solar system's structure, namely the existence of a core in the Kuiper belt. On this diagram, you can see that the axes of the orbits of the most distant known bodies in the Kuiper belt are strangely clustered in similar directions, but also that along their orbits, these bodies themselves are grouped together in the same cosmic region. Researchers say these characteristics have just a 0.007% chance of occurring by chance. However, this can be explained by simulating a celestial body about 10 times Earth's mass, on an orbit opposite the previous ones and currently distant from the others. This is Planet 9, also called Planet X by some. For the most skeptical about this planet's existence, 9X or whatever it's called now, Batajian and Brown were initially skeptical themselves and understood the hostile reactions from fellow scientists when they proposed their hypothesis. But if we are to believe some statements from their father, the hypothesis supported by the two researchers is crazy enough to be accurate. However, not everyone will be fully convinced until the image of the 9th planet clearly appears in telescopes. So you see, dear friends, that even in the 21st century, as our dreams, our hypotheses, and our technical means are used to constantly push the visible distances to the edge of the universe, we still don't know everything about our next door neighbors, that is, the planets of our own solar system. And that's the magic of the cosmos. You may not know it, but the most distant star ever observed so far is called Max J 114922223, Lensed Star 1. And it's located 5 billion light years from Earth. In kilometers, that's a lot of zeros. A light year is about equal to 9,500,000,000,000 kilometers. So this star would be, get this, 47.5 trillion kilometers away from Earth. These numbers are truly astronomical and can make you lose your mind a little. So, to give you an idea, that's about, pay attention, 316 billion times the distance from the Earth to the Sun, or even more impressive, 123 trillion times the distance from the Earth to the Moon. That's why it won't be useful for Braun and Batajian to look that far in order to better understand the workings of our solar system. Thank you.